Okay, so today we're going to get a little bit more in depth with the right triangle trig that we started talking about a couple days ago. So we're going to look a little bit more in depth at how we can use the trig functions to help us deal with right triangles and finding missing pieces of their information, whether it's angles or sides. So the first is we can use trig functions . We can use trig functions to find a missing side length or angle measure of a right triangle. So in example 1, we have a right triangle that's given to you in that block of, in that table. And they want us to find the missing value for x given this right triangle. And normally, if we're dealing with side lengths, we can use our Pythagorean theorem, right? Our a squared plus b squared equals c squared. However, in this particular problem, we can't use Pythagorean theorem because we only know one side length of this right triangle. We're missing the other piece. So starting out, we're going to set up our triangle, labeling our side lengths in relationship to our interior angle that's given. And we're going to use our trig functions to solve for this missing value of x. So the first is, I'm going to start off by just writing SOHCAHTOA up top. Remember, SOHCAHTOA stands for the SO sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So starting out, the first thing I want to do is I want to label my side lengths that are given to me, values that are given to me in relationship to my interior angle. So here I have my interior angle of 30. 8 in relationship to this interior angle. I know this is my hypotenuse, so I'm going to label it with my hypotenuse. I also know that my x side in relationship to my 30-degree angle that's labeled on the inside is my adjacent side length. So if this is the only pieces of information that I have given to me in this right triangle, I have my adjacent and my hypotenuse. I know that right off the bat my cosine is going to be the trig function that I will be using. So in this case, I'm going to set this up as I know my cosine of my angle, which is theta, is equal to my adjacent side over my hypotenuse. So now I'm just going to fill in the pieces of information that I know. The first is cosine of theta. Well, I know my theta is 30. I'm given my interior angle. So I know the cosine of 30 is equal to my adjacent leg, which I don't know. It's given to me as x, over the hypotenuse, which I do know, which is 8. At this point, I can actually cross multiply. But before I do that, I want to make sure I stack both sides to be the same. So since my right-hand side is given as a fraction, I'm going to stack my left-hand side as a fraction, putting it over 1. And then I can cross multiply to solve for x. So 1 times x is equal to 8 times cosine of 30. So I can take my calculator. The first thing I want to make sure I do is if I go to my mode button. So if I go to my mode and I click on mode, I want to make sure that I'm in degree mode because I'm dealing with degrees in this right triangle. So I want to make sure I'm in degree mode. And so I'm going to type in 8 times the cosine. My cosine button is given 2 steps up from my 8 button, so cosine of 30 degrees. And if I hit enter, I get that x is going to equal roughly 6.93 if I round to the hundredths. So that's my value for x. And I did that using my trig functions. There was no Pythagorean theorem that was part of example 1. So at this point, we're going to skip over the now you tries. The now you tries that's labeled numbers 1, 2, and 3. 1, 2, and 3. will be homework or classwork the next time that we all get together. So let's move on to example 2.